In today's lesson, we'll be learning how to graph the slope-intercept form of a line, which is y equals mx plus b. As mentioned in our previous lessons, m represents slope, while b represents the y-intercept. Previously, you knew slope as the rate of change, and you knew the y-intercept as the initial value. The y variable represents the dependent variable, while the x variable represents the independent variable. In our first example, we're going to learn how to graph y equals 2 over 3x plus 3. With our equation, the first thing you want to do is identify the key pieces of information. So let's identify the slope, and we're going to identify the y-intercept. So let's write that on the side. Slope is equal to 2 over 3, while the y-intercept is equal to positive 3. We are not going to write in the positive sign. Remember, m is the variable you use to represent slope, and b is the variable you use to represent the y-intercept. The first piece of information we're going to use is the y-intercept. If you recall, that is the y-axis, and this is the x-axis. Therefore, the y-intercept of positive 3 is going to be right over here, and I'm going to make a little dot. The second piece of information we're going to use is the slope. If you recall, slope is equal to rise over run. Therefore, 2 would be the rise, and 3 would be the run. So let's go ahead and do a rise of 2 and a run of 3. I'm going to zoom in over here. The rise is 2 units, so I'm going to label that. The rise is equal to 2, and the run is 3. So you're going to run this way 3 units. So I'm going to label that the run is equal to 3. At this very point, we're going to draw ourselves a dot. Once we have these 2 dots, you're going to connect these dots just like if you were in elementary school. Now, you would want to do this with a ruler. Since I don't have a ruler with this app, I'm going to have to do this freehand, so it's going to look a little messy. So I'm going to draw a straight line through these 2 coordinates. As you can see, we've just drawn our line, which is y equals 2 over 3x plus 3. We first started with the y-intercept, and then we used the slope values to find a second point, and then we connected the dots. And before we finish, let's just double check our work. If you look at the slope value is positive. And when we have a positive slope value, the line should be pointing upwards. And it is. Therefore, we've done our work correctly. In our second example, we want to graph the equation y equals negative 3 over 4x minus 2. Again, the first thing we want to do is extract these important pieces of information. We want to extract the slope. So m is equal to negative 3 over 4. And the y-intercept, b, is equal to negative 2. It's important you include the sign over here. Remember, m is the variable used for slope, and b is the variable used for the y-intercept. We're going to start with our y-intercept. Don't forget, this is the y-axis, that is the x-axis. Therefore, the y-intercept is negative 2. And I'm going to draw a little dot where negative 2 is, and it is right over there. If you recall, slope is also equal to rise over run. Therefore, if you look back at our slope value, negative 3 is going to be the rise, and positive 4 is going to be the run. Let's go ahead and use this slope value to create a second coordinate. So I'm going to zoom in over here. If you recall, the rise is -3. Therefore, we're going to go down 3 units. And I'm just going to label this rise is equal to -3. Remember, if the rise is negative, you're going down. You are not going upwards, you're going down. Now, the run is 4 units. You're going to move 4 units to the right like so, and I'm going to label this run is equal to +4. Once you've done that, you can create a second coordinate right over here. And just like our previous question, once you have those 2 dots, you're going to connect the dots just like as if you were in elementary school. And again, this is going to be a little bit messy because I do not have a ruler and I'm going to freehand this. So our line is going to look something like this. And it's important you put those arrows at the end because this means this line is going forever in either direction. Let's recap what we just did. We first started with our y-intercept value of -2. Afterwards, we used our slope value to find a second coordinate. Once we found a second coordinate, we connected the 2 dots with a line, and that line is y equals -3/4x minus 2. And before we finish, I want you to take a close look at this slope value. This slope value is negative. Since it is negative, that means this line must be pointing downwards. In our third example, we're going to look at the line y equals 4. Now, as soon as you see the equation of this line, alarm bells should be going off in your head. Remember, the form of a line in slope-intercept form usually looks like this: y equals mx plus b. However, this equation looks nothing like y equals mx plus b, and that is because it is one of these special cases. So I'm going to make a little note. This is a special case. If you saw our last video, this is either a horizontal or vertical line. Before we try graphing this line, I want you to label the axis. That is the y-axis, and that is the x-axis. If you look at the equation of our line, it says y equals 4. That means you're going to look at the y-axis, and you're going to look specifically at the number 4, which is right over here. Okay? That means that this is a horizontal line, because no matter what point on the line you choose, the y-coordinate is always going to be 4. I'm going to prove it to you right now. So I'm going to choose any 2 coordinates on this line, and we're going to examine what the numbers are. So I'm going to choose that. That coordinate is -3 and 4. And I'm going to choose that. And the coordinates are 2 and 4. As you can see, it is the y-coordinate, which is always 4. And that is why the equation of the line is y equals 4. In our last example, we're going to look at the line x equals 5. Once again, you should notice that this equation of a line looks nothing like the general equation of a line, which is y equals mx plus b. At this point, alarm bells should be going off in your head, and you should remember that this is one of those special cases, okay? So it can either be a horizontal line or a vertical line. When you look at the equation of the line x equals 5, pay careful attention to this. The variable is x. I want you to immediately think of the x axis, okay? Before we begin, let's go ahead and label these axes. So that would be the y-axis, and this would be the x-axis. So as we saw before, x is equal to 5, and when you see x, I want you to think of the x-axis. So look at the x-axis. I want you to find 5. I then want you to put a dot at 5. All right? At this point, you should remember that this is a vertical line. And I'm going to draw a vertical line like so. You can choose any point on this vertical line, and the x-coordinate of whatever point you choose will always be 5. I'm going to go ahead and prove that to you right now. So I'm going to randomly choose this point over here. That is 5, negative 3. And I'm going to randomly choose a point up here. That is 5, 3. If you recall, a coordinate is made up of both an x and y coordinate. An x and y coordinate. If you look closely, you'll notice that the x coordinate always stays the same. The x coordinate is always equal to 5. And that is why the equation of this vertical line is x equals 5.